Welcome everybody. So we're now going to think about what happens for constant acceleration when I'm moving in two dimensions. So I have both a set of constant acceleration equations for the x direction and a mostly identical set in the y direction. The only thing I've done is change the subscripts on all of the little quantities. One thing you'll note is that means we have a lot of quantities now. We've almost doubled the amount of quantities that we're going to be making use of. And the other thing to note is that there's one quantity, time, which doesn't get distinguished between the x and y directions. And that's going to be really powerful for us when we are solving problems. One extra step that I want to take is I want to think about what it means to have constant acceleration. It really means that the acceleration is not changing in magnitude or in direction. And in some sense, that means that I'm a little bit overspecified here because I could choose my coordinate axis to point in the direction of the acceleration. And then not only do I have constant acceleration, but I have acceleration which is 0 in one of the two directions. And you can pick either direction for the acceleration to be 0. I'm going to go ahead and for the moment pick the x direction, which means I just get to go erase all of these pieces that have acceleration in them, which you can see simplifies my equations quite a bit. Put a 0 in here for the acceleration in the x direction. And now I'm going to have a little bit of an easier time going back and forth in between these equations. Just like for motion with constant acceleration in one dimension, I now can ask questions like, well, if I know Vx and Vx initial and time, can I figure out something about Vy or Ry initial? So there's lots of questions that I can ask by going back and forth between these equations. One last step that I want to think about is that there's a particular case of motion with constant acceleration, which we will study frequently in physics. And that's the case where the acceleration is due to something which is falling near the surface of the Earth. And we'll see later in the course how you can build a model for that. But right now, we're going to take as a given that if you have an object near the surface of the Earth that's moving around in free space, you can write that the acceleration, I'm going to write it as a vector first, that the acceleration should be minus g in the y direction, or you might sometimes see this written as g in the minus y direction, where g is a constant that is approximately 9.81 meters per second squared. This might be a number that you've seen before if you've taken other physics classes. And for our purposes, when we're doing calculations, we will often further approximate this as 10 meters per second squared, depending on the level of precision that you feel you need in your calculation.